13 billion years ago, the universe should still have been a chaotic place, with the very first galaxies only beginning to form. But since the James Webb Space Telescope recently discovered objects that appear to have matured far too early at the edge of the universe. These tiny red dots are forcing scientists to ask a deeply unsettling question. Do we truly understand how the early universe formed? Welcome to Astrexo. Space documentaries bring us closer to the mysteries of the universe. Since being launched into space on December 25, 2021, the James Webb Space Telescope has observed more than 32,000 hours of deep space data. And in almost every image of the early universe, astronomers kept seeing the same thing: tiny red dots scattered throughout the ancient darkness of space. At first, they were believed to be extremely distant galaxies whose light had been redshifted by the expansion of the universe. But the closer scientists looked, the stranger everything became. These objects were far too bright for their size, and they appeared to contain more mass than the young universe at that time should have been capable of producing. Some scientists now believe they could be connected to the formation of the first supermassive black holes in the universe, while others think this may be evidence of an entirely new kind of object that science has never seen before. The problem is that, according to current cosmological models, structures like these should not exist so soon after the Big Bang. At that time, the universe was only a few 100 million years old. The first galaxies should still have been slowly gathering hydrogen gas and forming their earliest generations of stars. But these mysterious red dots looked more like objects that had already reached an almost fully developed state. They were so compact that the light of an entire galaxy seemed compressed into an incredibly small region of space. And what puzzled scientists most was that no one truly knew what they were. At first, many researchers believed they might simply be starburst galaxies, where billions of young stars were forming at an extreme rate. That could explain why they appeared so bright. But when the James Webb Space Telescope analyzed their light into detailed spectra, things began to stop making sense. These red dots were emitting a pattern of light signals unlike anything ever seen from any ancient object previously observed. And it was at that moment that the real mystery truly began. To understand what was happening, astronomers were forced to break the light from these red dots into detailed spectra. Every element leaves behind its own unique signature within a light spectrum. Simply by looking at the gaps appearing in that spectrum, scientists can determine what an object is made of, how hot it is, and what is happening inside it. And when the James Webb Space Telescope did this with the mysterious red dots, the results turned out to be even stranger than anyone had expected. These objects emitted enormous amounts of red and infrared light, while also producing large quantities of ultraviolet and blue light. But in the middle region of the spectrum, the amount of light dropped sharply in a highly unusual way. That created a V-shaped signal pattern almost never seen in any ancient object ever observed in the early universe. At first, researchers believed cosmic dust might be responsible. In space, dust tends to absorb blue light more effectively than red light, making distant objects appear redder when observed across vast cosmic distances. But the problem was that the amount of dust required to create such an intense red color was far greater than what early galaxy models allowed. According to the calculations, these red dots would need hundreds of times more dust than stars from that era should have been capable of producing. And that was the moment the first major theory began to collapse. But that was only the first problem. The second problem was far more difficult to explain. These red dots were not just unusually red, they were also so incredibly bright that they almost should not have been able to exist in such a young universe. To produce the amount of light observed by the James Webb Space Telescope, scientists calculated that they would need to contain an extraordinarily high density of stars packed into an extremely small region of space. In some cases, the stellar density inside them appeared so extreme that the systems themselves should have become unstable. But if billions of stars were truly compressed that tightly together, the entire structure would become violently unstable. In other words, if these red dots were simply ordinary star-forming galaxies, they should not have remained stable long enough for James Webb to observe so many of them. And then astronomers realized something even stranger. Even though James Webb has the highest resolution ever built, most of these red dots still appeared as single points of light in space. They showed none of the clear structures expected from a normal galaxy. No spiral arms. No chaotic shapes like the early galaxies that should have existed at that time. Instead, they looked more like concentrated points of light surrounding one incredibly powerful energy source reaching temperatures above 12 million degrees Celsius. And it was at that moment that a new theory began to emerge. What if these red dots were not galaxies filled with stars? What if their light was actually coming from something far more extreme? This idea quickly captured the attention of researchers. In the modern universe, nearly every large galaxy contains a supermassive black hole at its center. When matter falls toward a black hole, it does not plunge straight inside immediately. Instead, gas and dust begin orbiting the black hole at enormous speeds, forming a blazing accretion disk. Friction and gravitational forces within this disk can heat matter to millions of degrees, causing it to release tremendous amounts of light. In fact, active black holes are among the brightest objects in the entire universe. And this theory seemed to explain many things at once. A highly active black hole could generate extraordinary brightness within an extremely small region of space. That matched the way these red dots appeared as concentrated points of light rather than normal extended galaxies. In addition, surrounding a black hole's accretion disk, there is often a thick layer of gas and dust known as a torus. If we observe this torus from the side, the dust absorbs blue light and ultraviolet radiation while allowing red and infrared light to pass through. And that also matched the strange colors the James Webb Space Telescope was seeing. For a short time, it seemed as though the mystery had finally been solved. But then, another detail shattered the entire theory. Active black holes almost always emit extremely powerful X-rays from the superheated matter surrounding them. This is one of the clearest signatures used to confirm the existence of a black hole feeding on matter. But when scientists examined the X-ray data from these mysterious red dots, they found almost nothing. There were no strong X-ray emissions like those an active black hole should have produced. If these objects were not ordinary star-forming galaxies, and not active black holes as we understand them, then what exactly was the James Webb Space Telescope seeing at the edge of the universe? To answer that question, astronomers began studying these red dots in greater detail than ever before. And the deeper they looked, the more they realized that these objects seemed to be sending completely contradictory signals. Some characteristics suggested they resembled active supermassive black holes. But other features looked more like extremely hot young stars inside early galaxies. It was almost as if two entirely different kinds of objects were somehow existing within a single source of light. And then, in 2024, a research team using the James Webb Space Telescope discovered an especially strange object nearly 12 billion light-years away. Scientists named it the Cliff. It became one of the red dots with the most extreme spectral signatures ever observed. What made the Cliff so important was that it contained an almost perfectly vertical Balmer break, stronger than anything previously seen in any known ancient object. In astronomy, a Balmer break is a signal indicating that large amounts of hydrogen exist between the light source and the telescope. But the Cliff was different. Its signal was so sharp that it almost suggested the object was surrounded by an incredibly dense and remarkably uniform layer of hydrogen. And strangely, at the very same time, the spectral data also indicated that inside this object there appeared to be an energy source similar to a supermassive black hole. An object carrying the characteristics of both a star and a black hole at the same time. The idea of a black hole star sounds almost like science fiction. But what makes it remarkable is that it is actually grounded in serious physics. According to this theory, in some extremely dense regions of the early universe, matter may have collapsed so rapidly that it formed a young black hole before the surrounding gas cloud had enough time to become normal stars. But instead of blasting away the surrounding gas like what usually happens, the black hole remained trapped inside an enormous shell of dense hydrogen. From the outside, this object could appear like a gigantic glowing star. But at its core was a black hole consuming matter at an extraordinary rate. This could explain almost all of the strange features observed by the James Webb Space Telescope. The thick hydrogen layer surrounding the object would absorb most of the X-rays emitted by the black hole, making it nearly impossible for telescopes to detect the powerful X-ray signals normally expected. At the same time, this gas shell would also cause the object to emit huge amounts of red and infrared light, exactly like what James Webb is seeing. It could even explain why these red dots appear both incredibly bright and incredibly compact at the same time. But what makes this theory especially important lies in a much bigger problem. For decades, scientists have struggled to explain how the first supermassive black holes in the universe could have formed so quickly. Because even if a black hole continuously consumed matter at the maximum rate allowed by current models, it still would not have enough time to grow to billions of times the mass of the Sun only a few 100 million years after the Big Bang. But if black hole stars truly existed, they might represent the missing phase of ultra-rapid growth that science has been searching for. A pathway that allowed primordial black holes to grow far faster than we ever believed possible. In fact, this idea is not entirely new. Back in 2008, astrophysicist Mitchell Beagelman proposed the existence of a theoretical object known as a quasi-star. According to his model, the early universe may have contained enormous clouds of hydrogen gas collapsing directly under gravity. At the center of these clouds, a young black hole would begin to form and continuously consume the surrounding matter. But unlike normal stars, the energy emitted by a quasi-star would not come from nuclear fusion. It would come from the black hole at the core, absorbing matter at an extraordinary rate. That process would cause the entire outer gas shell to glow like a gigantic star. And remarkably, this model seems suspiciously consistent with what the James Webb Space Telescope is observing from these mysterious red dots. It could explain why these objects are so bright, despite being incredibly compact in size. It also explains why their spectra carry both the signatures of hot hydrogen and the signs of matter orbiting an extremely powerful gravitational source. Most importantly, this theory may also solve one of the greatest paradoxes in modern cosmology: the origin of supermassive black holes. Today, we know that nearly every large galaxy contains a supermassive black hole at its center. Some of them contain masses billions of times greater than the Sun. But the problem is that James Webb has already discovered many gigantic black holes existing only a few 100 million years after the Big Bang. According to standard growth models, they simply should not have had enough time to grow that large that quickly. It would be like seeing a massive ancient tree only days after planting the seed. And for years, no one truly understood what allowed the first black holes to grow so fast. But if black hole stars or quasi-stars truly existed in the early universe, they may be the missing link behind the entire story. What especially captured the attention of scientists was that these red dots seemed to appear only during a very short period in cosmic history. The James Webb Space Telescope observed them commonly existing from around 600 million to just over 1 billion years after the Big Bang. But after that, they almost completely disappeared from the later stages of the universe. This has led many researchers to believe that black hole stars may not be a long-lasting type of object at all, but rather an extremely brief transitional phase in the formation of supermassive black holes. A phase humanity never had powerful enough technology to observe before. And if that is true, James Webb may have just witnessed one of the most important eras in the evolutionary history of the universe. The moment when the first black holes began growing into the gigantic gravitational monsters that now exist at the centers of galaxies. But even though the black hole star theory is becoming one of the most convincing explanations today, science still does not have a final answer. There are still many unanswered questions. Researchers still do not know exactly how the dense hydrogen shells surrounding these objects were formed. They also do not know how long the black hole star phase lasts before the outer gas layer is completely blown away. In fact, there is still a possibility that these mysterious red dots are not black hole stars at all, but something entirely different that we have never even imagined. And that is what makes this discovery so important. Because sometimes in science, the greatest value of a discovery is not the questions it answers. It is the realization of how much we still do not understand about the universe. For decades, modern cosmological models have helped humanity explain how galaxies, stars, and black holes formed after the Big Bang. But now, with only a few tiny red dots at the edge of the universe, the James Webb Space Telescope may be revealing that the true story of the early universe is far more complex than we ever imagined. And perhaps the most astonishing part is that humanity has only just begun to see them. Because James Webb is still continuing to look deeper into the past of the universe. Every year, this telescope sends back additional terabytes of new data from regions of space never explored before. Which means mysteries like the little red dots may be only the beginning. There may still be stranger objects out there. Older objects. Objects that could even challenge many of the laws of physics we currently believe to be true. And if the history of astronomy has taught us anything, it is that every time humanity looks farther into the universe, we rarely find what we expected. Instead, we discover things that make our old understanding feel incomplete. One of the reasons this discovery has sent shockwaves through the astronomical community is because it could directly affect the entire model of structure formation in the early universe. According to the current Lambda CDM model, matter after the Big Bang needed hundreds of millions of years to gradually gather into the first galaxies. The first stars are believed to have appeared around 100 to 200 million years after the Big Bang, before galaxies slowly evolved through collisions and mergers over the billions of years that followed. But the James Webb Space Telescope is now seeing objects that appear to have evolved far too quickly for that timeline. Some little red dots may contain amounts of matter equivalent to billions of stars when the universe was only around 700 million years old, roughly just 5% of its current age. And it is this extraordinary growth rate that is creating problems for existing cosmological models. If supermassive black holes truly can form that quickly, then the evolution of the early universe may have been far more violent and chaotic than predicted. For years, scientists believed the first black holes formed from the collapse of the earliest generation of massive stars, known as population 3 stars. These stars may have been hundreds of times more massive than the Sun, and after dying, they would leave behind primordial black holes. But even if those black holes continuously consumed matter at the Eddington limit, they still would have had almost no chance of growing into supermassive black holes only a few hundred million years after the Big Bang.
Here's the inconsistency.
This has been one of the biggest unsolved problems in astrophysics for decades, and the little red dots may finally be providing the first clues toward an answer. Some models suggest that instead of forming from individual stars, the first black holes may have formed directly from the collapse of enormous gas clouds, with masses reaching hundreds of thousands or even millions of times greater than the Sun. This process is known as a direct collapse black hole. If that truly happened, primordial black holes would have started out far larger from the very beginning, allowing them to grow into supermassive black holes much faster than older models predicted. And the conditions required for direct collapse black holes seem surprisingly consistent with what the James Webb Space Telescope is observing in the little red dots. Extremely compact objects, rich in hydrogen, containing enormous densities of matter, and emitting extraordinary amounts of energy from an incredibly tiny region of space. However, even the direct collapse black hole theory still does not fully explain the mystery. For an enormous gas cloud to collapse directly into a black hole, it must avoid fragmenting into normal stars. and that is incredibly difficult. In most cases, when hydrogen gas contracts under gravity, it quickly cools down and breaks apart into smaller regions that begin forming stars. But in the case of a direct collapse black hole, the entire gas cloud must remain at temperatures close to 10,000 Kelvin, hot enough to prevent fragmentation. That suggests the early universe may have been far more extreme than current models describe. Some studies suggest that ultraviolet radiation from the first galaxies prevented molecular hydrogen from forming inside nearby gas clouds, stopping the gas from cooling and forcing the entire mass to continue collapsing into a single, gigantic structure. If that is true, the little red dots may be the remnants of the first direct collapse events in cosmic history. What makes this especially remarkable is that the James Webb Space Telescope is finding these objects far more frequently than expected. In surveys, such as JADES and SEERS, researchers discovered hundreds of little red dot candidates within only a tiny patch of sky. That suggests they may once have been a common phase in the formation of the first galaxies. And if that is true, the history of galaxy evolution may need to be rewritten. Instead of growing slowly over billions of years, some gigantic black holes in the early universe may have appeared almost immediately. This is especially important because supermassive black holes do not simply exist at the centers of galaxies. They directly influence star formation, gas structure, and the long-term evolution of entire galaxies. If the little red dots truly are evidence of primordial black holes growing at extraordinary speeds, then the James Webb Space Telescope may be witnessing the very first stage in the formation of modern galaxies. However, no matter how convincing the black hole star or direct collapse black hole theories may sound, scientists still face one enormous problem. The James Webb Space Telescope does not directly see these objects the way we see planets or stars with our eyes. What the telescope observes is only light that has traveled across space for more than 13 billion years before finally reaching Earth. And that makes studying the early universe incredibly difficult. The light from the little red dots is extremely faint. In many cases, James Webb must observe continuously for dozens of hours just to collect enough signal for analysis. Which means all current data is operating near the absolute limits of modern observational technology. Even a small change in the way spectral data is processed could alter how we interpret these objects. Some researchers believe the little red dots may simply be active black holes hidden behind thick clouds of gas and dust. Others argue they are early galaxies forming stars at extreme rates. But there is also the possibility that current models are fundamentally underestimating how quickly the early universe evolved. And if that is true, the entire timeline for the formation of the first galaxies may need to be revised. That is why this discovery is so important. Because every possible explanation carries enormous consequences for our current understanding of the universe. If the little red dots truly are black hole stars, they may explain how the first supermassive black holes grew so unbelievably fast. If they are extreme star-forming galaxies, that would mean the early universe evolved far more violently than predicted. But if neither theory is completely correct, then the James Webb Space Telescope may be witnessing a type of object that modern astrophysics has never encountered before. What makes this especially remarkable is that this is not the first time the James Webb Space Telescope has challenged current cosmological models. In only its first few years of operation, the telescope has repeatedly discovered unusually massive galaxies existing far too soon after the Big Bang. Some galaxies already appeared to contain tens of billions of stars when the universe was less than 1 billion years old. This led many researchers to question whether the first galaxies may have formed much faster than predicted. And the little red dots could be part of that same story. If these objects truly are connected to primordial black holes growing at extraordinary speeds, they may have played a major role in accelerating the formation of early galaxies. Because when black holes consume matter, they do not simply release energy. Powerful radiation streams from the regions surrounding black holes can also heat hydrogen gas, compress matter, and directly influence the rate of star formation throughout the surrounding galaxy. That means the first black holes may not have merely appeared alongside galaxies. They may have actively shaped the evolution of galaxies from the very beginning. And if that is true, the role of black holes in cosmic history could be far greater than we ever imagined. For many years, black holes were often viewed as the final outcome of stellar and galactic evolution. But James Webb is opening the door to a very different possibility. In the early universe, black holes themselves may have appeared first and driven the growth of the earliest cosmic structures. This is especially important because nearly every large galaxy in the modern universe, including the Milky Way, contains a supermassive black hole at its center. Sagittarius, a star, the black hole at the center of our galaxy, has a mass roughly 4 million times greater than the Sun. Meanwhile, some black holes inside distant quasars may contain masses tens of billions of times greater than the Sun. But until now, science has never truly understood how such enormous objects could have formed so quickly in the young universe. And perhaps those tiny red dots James Webb is now observing are part of that answer. But perhaps the most astonishing thing about the little red dots is not simply what they are. It is how they remained hidden from humanity for so long. Before the James Webb Space Telescope, telescopes like Hubble Space Telescope were not sensitive enough at infrared wavelengths to clearly observe these objects. Their light had been stretched by the expansion of the universe for more than 13 billion years, shifting most of it deep into the infrared spectrum. That is why James Webb was designed with a massive 6.5-meter primary mirror and extremely sensitive infrared instruments. It does not simply see farther than Hubble. It can observe an ancient era of the universe that was previously almost invisible to humanity. And within only a few years of operation, James Webb has repeatedly discovered objects that do not fit comfortably within existing models. The little red dots are one of the clearest examples. They suggest the early universe may have been far more complex than science once believed. Galileo Galilei discovered moons orbiting Jupiter and shook the geocentric model that had existed for thousands of years. Edwin Hubble proved that the Milky Way was not the entire universe, but only one galaxy among billions of others. And now, James Webb may be opening a similar chapter, not by destroying current models, but by revealing that they are still missing major pieces of the universe's earliest history. Because no matter what the little red dots ultimately turn out to be, Their existence alone is already forcing scientists to reconsider how the first black holes formed, how quickly early galaxies evolved, and how matter assembled itself after the Big Bang. Right now, scientists are continuing to observe the little red dots using multiple instruments in an effort to find a more precise answer. One of the biggest goals is determining whether these objects truly contain active black holes or are simply extremely dense early galaxies. To do that, researchers are combining data from the James Webb Space Telescope with the Chandra X-ray Observatory, the Atacama Large Millimeter/Submillimeter Array, and many other ground-based observatories, because every wavelength of light reveals a different part of an object. X-rays can expose activity surrounding a black hole. Radio waves reveal the motion of gas and dust, while infrared light allows James Webb to see through the dense layers of matter in the early universe. And the more data scientists collect, the more fascinating this mystery becomes. Some little red dots appear to contain gas moving at speeds reaching thousands of kilometers per second, a signature often associated with the immense gravitational forces surrounding black holes. But other objects do not fully match that model. This has led many researchers to believe that the little red dots may not represent just a single type of object. There may be multiple different structures hidden within this group that James Webb still does not yet have enough data to completely separate. And that is something that often happens in astronomy. Whenever new technology opens a window into a previously unseen region of the universe, objects that initially appear similar often turn out to be entirely different phenomena. The same thing happened with quasars in the last century. When they were first discovered, scientists could not understand why those tiny points of light emitted more energy than entire galaxies. Only years later did humanity realize they were active supermassive black holes at the centers of distant galaxies. And perhaps the little red dots represent a similar moment in the history of modern astronomy. The first signal that the early universe contained far more extreme structures than we ever imagined. In the coming years, the James Webb Space Telescope will continue observing the little red dots to determine their exact structure and energy source. One of the most important goals is discovering whether these objects truly contain rapidly growing black holes at their cores. If that is confirmed, the little red dots could become the first evidence showing that supermassive black holes began forming almost immediately after the Big Bang. Over the next decade, new generation telescopes such as the Nancy Grace Roman Space Telescope and the Extremely Large Telescope will also join the effort to study these objects. With more powerful observation systems, scientists will be able to analyze the motion of gas and matter surrounding the little red dots in far greater detail than today. That could finally reveal whether the gravitational forces inside them truly come from supermassive black holes. And this is still only the beginning of the James Webb era. The Hubble Space Telescope took more than 30 years to completely transform humanity's understanding of the universe. Meanwhile, James Webb has only been operating since 2022, which means many of its greatest discoveries may still lie ahead. The little red dots may be only the first sign that the early universe evolved far faster and far more violently than predicted. Perhaps the first black holes appeared earlier. Perhaps the first galaxies grew faster. And perhaps the earliest cosmic structures formed in ways completely different from what science once believed. That does not necessarily mean current models are entirely wrong, but it does reveal that our understanding of the early universe is still missing many critical pieces. Up to this moment, scientists still do not have a final answer for the little red dots. It is possible that within the next few years, new data from the James Webb Space Telescope will prove they are simply black holes hidden behind dense clouds of gas and dust. But it is also possible that they will open the door to an entirely new era of astrophysics. An era in which the first black holes, the first galaxies, and the first cosmic structures formed far faster than any current model predicts. And that is exactly how science moves forward. Not by everything perfectly matching old theories, but through discoveries that force us to re-examine the things we once believed were certain. The little red dots may appear to be nothing more than tiny points of light hidden within James Webb's data. But they represent one of the greatest questions in modern astronomy. How did the early universe truly form? And perhaps the most astonishing part is that humanity has only just begun observing that era with enough detail to realize the true story of the universe may be far stranger than we ever imagined. Perhaps in the future, the little red dots will be fully explained by the physics models we already have today. But it is also possible that they will become one of the discoveries that forces humanity to expand its understanding of the early universe in ways never imagined before. Because throughout the history of science, the greatest revolutions have often begun with the smallest signals. An orbit that failed to match the calculations. An unusual light hidden inside the data. Or a few faint red dots sitting at the very edge of the observable universe. And now, the James Webb Space Telescope is seeing those signals from the most ancient era humanity has ever observed. A time when the first galaxies were beginning to emerge, when the first black holes may have been forming, and when the earliest structures of the universe still existed in a state of primordial chaos. We still do not know exactly what the little red dots truly are. But perhaps that is precisely what makes this discovery so important. Because sometimes the most valuable things in science are not the final answers. They are the discoveries that reveal just how much of the universe we still do not fully understand. And perhaps somewhere within those tiny red points of light that James Webb is observing, there exists a missing piece in the story of how the universe began. And perhaps that is what truly makes the James Webb Space Telescope so extraordinary. It is not simply helping humanity look farther into space. It is allowing us to look back toward the moment when the very first chapters of the universe were written. Every dark region James Webb observes contains light that traveled for billions of years before finally reaching Earth. Which means every little red dot is not just an object located incredibly far away. It is a surviving fragment of ancient time itself from the earliest age of the universe. And the deeper we look, the more we realize that the early universe may not have been nearly as simple as our models once described. Perhaps the first black holes appeared almost immediately after the Big Bang. Perhaps the first galaxies evolved far faster than predicted. Or perhaps there are still entire stages in the evolution of the universe that modern science has never even discovered. The little red dots may only be the beginning of those discoveries. And in the years ahead, James Webb may continue uncovering even stranger objects at the edge of the observable universe. Objects powerful enough to change how we understand the formation of galaxies, black holes, and the history of the universe itself. Because the deeper humanity looks into space, the more we realize one thing. The universe is always far more complex than we ever imagined. Even today, those tiny red dots still exist at the edge of the observable universe, more than 13 billion light-years away from us. Their light began its journey at the moment when the first structures in the universe were only just beginning to form. And now, for the first time in history, humanity finally has technology powerful enough to see them clearly. Perhaps the little red dots will become the key to explaining the origin of the first supermassive black holes. Or perhaps they will force modern science to rethink how the early universe evolved after the Big Bang. But no matter what the final answer turns out to be, the James Webb Space Telescope has already revealed one thing with absolute clarity. The early universe is still far more mysterious than we ever imagined. Thank you for staying with Astrexo until the end of this journey. If you enjoy stories of cosmic exploration like this, do not forget to like the video, subscribe to the channel, and share your thoughts in the comments below. Your support is what allows Astrexo to continue bringing deeper journeys into the greatest mysteries of the universe.